Welcome to The Explainer. Today, we're diving into a seriously fascinating research paper straight from Hewlett-Packard Enterprise. It's all about a massive new vulnerability lurking in our data centers and, more importantly, how we can actually fix it. You know, if you've been paying attention to enterprise tech lately, you probably noticed that autonomous AI agents are basically taking over complex IT tasks. But as this paper reveals, just handing AI the keys to our critical infrastructure, it introduces some pretty massive security blind spots that our current tools literally just cannot handle. So we're going to explore exactly what those threats look like and then unpack a brilliant new solution designed to stop them in their tracks.
Let's kick things off with a staggering number, 8 million. Actually, over 8 million. That is the number of weekly downloads from Model Context Protocol, or MCP, SDKs. I mean, wow. This isn't just a passing trend. It's an explosive, widespread adoption of AI in enterprise environments. It really shows us that organizations everywhere are just scrambling to integrate conversational AI to automate their day-to-day operations.
Now, just to make sure we're all on the exact same page, let's talk about what MCP actually does. Basically, it's the de facto standard that lets large language models seamlessly hook into external systems. Think of it as the technology that finally allows conversational AI to step out of that little chat box and directly manage critical infrastructure using natural language. So instead of a human operator clicking through endless menus or writing out these massive, complex scripts, they can just type an instruction. The AI uses MCP as the bridge, goes out and does all the heavy lifting. Pretty cool, right?
Okay, so here's our roadmap for today's explainer. We're going to cover 1. The AI infrastructure problem. 2. Why traditional defenses fail. 3. We'll meet Infrastructure Sentinel. 4. Look at its 4 defense layers. 5. Check out some real-world testing results. And finally, 6. We'll wrap up with trust and explainability. Let's get right into it.
Section 1. The AI infrastructure problem. So letting AI manage your servers is kind of a classic double-edged sword. As you can see here, the MCP server sits right in the middle of everything. It acts as a bridge, translating what the AI wants to do into really granular operations on external systems, like your databases, communication apps, or cloud storage. Now, on one hand, it's totally amazing that an operator can just type, restart unresponsive web servers, and boom, it's done. But on the other hand, this bridge introduces highly unpredictable, multi-layered security vulnerabilities. Literally every single arrow in this architecture is a potential new attack surface.
Section 2. Why traditional defenses fail. Now, you might be sitting there thinking, hey, don't we already have enterprise-grade cybersecurity for this? Well, we do, but here's the catch. Those tools are completely blind to this new taxonomy of conversational threats. We are looking at direct prompt injections, where an attacker explicitly tells the AI to just ignore its safety rules. And then there are indirect injections, where malicious instructions are stealthily hidden inside, say, a log file the AI is analyzing. Add in tool poisoning, context manipulation, credential exposure, and denial of service, and we have a very severe problem on our hands. And what's really terrifying is that these threats actually compound. A single prompt injection can corrupt the agent's multi-step planning, cascading into catastrophic system-wide data center failures. So the really crucial point here is the absolute mismatch in our defenses. Think of traditional firewalls and access controls like a static perimeter defense. They're essentially a bouncer checking IDs at the door. If you have the right ID, you're in. But that bouncer is completely blind to the dynamic, context-heavy, conversational nature of these new AI threats. The bouncer doesn't understand the nuance of a shady conversation happening inside the club, right? And that is exactly how these agents operate. Section 3. Meet Infrastructure Sentinel.
To solve this massive fundamental gap, the HPE researchers built an incredibly clever framework that shifts us away from static controls toward an adaptive, learning-based model. Instead of relying on pages and pages of complex Python code, the system uses what they call a Guardian LLM. This Guardian LLM interprets specific plain English policies, like the one right here, forbidding unapproved tools, and it applies contextual reasoning in real time. This is a real game changer because it completely democratizes security. It allows compliance officers and domain experts to just write the rules directly without having to rely on rigid, hard-coded logic.
Section 4. The 4 defense layers. Because those single-point filters fail so spectacularly against multi-step AI planning, Sentinel builds out a really robust defense-in-depth strategy. Instead of a bouncer at the door, it acts more like an undercover bodyguard. It actively tracks the AI agent through 4 distinct cognitive stages. First up is perception. That's filtering the initial user prompt. Second is planning, which validates the exact tools the agent intends to use. Third is action, serving as a final real-time check right before the code actually executes.
And fourth is memory, where it audits the outcome to learn and improve for next time. If we walk through this diagram following a hypothetical jailbreak command, say an attacker is trying to trick the AI into deleting some critical system logs, you can really see how the framework intercepts it. Let's say a super clever threat somehow slips past that initial perception stage. Well, it moves down the line and bam, gets caught at the tool selection or the runtime gating phase. It perfectly mirrors the AI's own reasoning action cycle, ensuring that if a threat is somehow missed at one layer, it's completely neutralized by the next.
Section 5. Real-world testing results.
Now, theory is great and all, but let's look at the hard data from actual tests run in real high-performance computing environments. Look at this table. Relying on an agent's base safety catches, almost nothing. We're talking under 10% detection. Even if you use a standard LLM as a filter, you only get up to about 60% or 25% detection, depending on the attack. But Infrastructure Sentinel, it pushes threat detection well above 85% and 90% across the board. And crucially, it does all of this while keeping false positives under 10%, so it doesn't interrupt your legitimate, safe operations.
Seriously, just look at this massive leap in detecting direct prompt injections specifically, going from a measly 5% detection rate with no guardrail up to over 90% with Infrastructure Sentinel. I mean, it definitively proves that just tossing in a basic LLM filter or simply crossing your fingers and hoping the foundation model is aligned properly is entirely insufficient to protect your critical infrastructure.
Section 6. Trust and Explainability.
So how does this cutting-edge academic research translate into actual enterprise-ready technology? Well, it really all comes down to transparency. By providing clear confidence scores and completely immutable, human-readable audit logs for every single action, the framework basically eliminates the scary black box nature of AI. When the Guardian LLM blocks an action, it doesn't just say no, it tells you exactly why, referencing those plain English policies. This totally satisfies strict governance features, making it incredibly ready for rigorous regulatory frameworks like the EU AI Act or SOC 2 compliance.
As we wrap up this explainer today, I really want to leave you with a bit of a provocative thought. The AI revolution in infrastructure management, it's already here. I mean, those 8 million MCP downloads we talked about totally prove it. But as these autonomous agents take the wheel in your data centers, you have to ask yourself, are your security systems ready to evolve from static, blind bouncers at the door to dynamic, context-aware bodyguards? It is absolutely a question every single IT and security leader needs to answer today.